The next talk or the next presentation will be done by Dan Wilcox, and while I'm talking, they just rebuilt the or set up a little bit. The system he's presenting, the software Zirkonium, is a project we are dealing with since 2004. I think we started already in the end of 2003. And in 2003, I had the idea to set up the sound dome here in the Cube. We had a project funded by the Land of Baden-Württemberg, and we were happy to have this amount of money to allocate to this project of spatial audio. And what you need for spatial audio are two things. One is the hardware, and one is the software. Both are necessary. At that time, no standardized software was there. There were some implementation of sound domes, but most of them were temporarily. You all know the Osaka sound dome, 1970, Stockhausen and the German pavilion at the World Fair. But this was up 6 months and then it was demolished. They tried to send it over to Berlin, but they couldn't get the money together to build it down, pack it, and send it over and unpack it. So nearly all of the installations were non-steady. The second problem we addressed with our project was to create a setup for the composers which is flexible. All the others, at that time, all the other installations you could do for this specific site. You do a composition for a specific environment of speakers, and then you could present it in that institution, that space, and that's all. And you couldn't present it somewhere else. And our idea was to create a software and hardware environment which is flexible. You can run it with 5 speakers or with 500 speakers. I mean, theoretically, not practically. There are not many spaces with 500 speakers. And as a follow-up of this idea, many performances have taken place in other spaces, China, US, and I don't want to start to mention all the performances, at least I have done, with the sound dome system in Cordoba, Argentina, for example. We always set up the speakers they had there, created the dome-like architecture, and then played the pieces there. And of course, the more speakers you have, the nicer is the system, and the better speakers you have, and the nicer is the sound. The question we were trying to answer is now the idea of a sound dome here in ZKM is fixed. And up to now, we have many sound domes on the world. For example, we set up a sound dome in Chengdu, in China. The first sound dome in China I think it was last year. And it was quite a successful project. And I visited some others, like in Stanford, they have a steady sound dome as well. So the idea was, since we have fixed or we have under control the hardware environment, what kind of support do we offer to the composers? And this is the question of the software. And we have already 3 different designs, and then is now at least, I think, the 4th or 5th developer working on Zirkonium. And we have always changed the context from a native application to a Max-driven application to a PD-driven application. Then Wilcox is an expert in many of open source projects. Zirkonium is not an open source project so far, but it's a public domain project. So all of you can download the software, have a look on the ZKM website for Zirkonium. And the question is to control or to define the functionalities inside Zirkonium. And there then Wilcox has done a great job to modify stability, to address precision, to change let's say the work the work process. And what he will present us is now the last version of Zirconium 3.4. That's, if I put together, that's after 14 years of Zirconium development, our current step, and I'm looking forward what he has to present.
You got me? Yeah, okay. Thank you, Ludger. Again, my name is Dan Wilcox. I'm an artist, engineer, musician, and performer, and I'm currently doing software development for the ZKM Hertz-Lab. And I always like to start with a little demo. So this is a piece, let's just see here. Yeah, Alexander Rodriguez. Back to that interface in a sec. So, Ludger did most of the overview. So again, Zirconium. I think of it as a sound. It's not just one application. It's more of a sound spatialization environment. There are multiple applications now, different contexts you can use it. So again, primarily developed for this space, for the Kubus Klangdom. So. Compared to Garth's presentation, it's sort of the opposite, that you need very much of a fixed installation for this to work. However, Zirconium is built around the idea that you can adapt it to different spaces by basically choosing different speaker layouts. So if you make a piece for this, you're not stuck with only being able to perform it here. You can sort of set up something similar with less speakers or more, and the idea is you should be able to run the same project with, the only difference being the spatialization and resolution based on the number of speakers. Okay, so a little bit of history from some old screenshots I pulled. So going back to 2006, the original version of Zirconium, called now Zirconium Classic or Mark I. How do you pronounce Shekhar's last name? Shekhar's name or his last name. Ramakrishnan. Yeah, this was originally by Shekhar Ramakrishnan. And then Zirconium Mark II, around 2012, from David Wagner. And this is sort of what was built in Max. And now Zirconium 3 was, the original development of this was from Professor Chikashi Miyama. And this is built around, basically, with Mark II, you had a sound spatialization engine that you would send sound into, and then you could position it. And then a special editor was added that you could then draw trajectories. And Mark III was built around this idea of, let's have the trajectory editor basically get a lot bigger and then integrate the spatialization engine inside. And then now I've been working on Mark 3.4, which is essentially trying to get a lot of the things that were pioneered in Mark III and getting them to work better, as is usual with a lot of software development. First you make it work, and then you make it work better. And I have a number of ideas which I can talk about more towards the end of how I see Zirconium development can continue in the future. But right now I'm basically continuing Chikashi's work and making it more useful and work well. So that's just a quick overview, and it's more fun just to get right into it. So originally the proposal for this workshop was to be, well, it's not really a workshop now, but would be more like 2 or 3 hours, and we could sort of sit here and work together. So I'm hoping later we'll have some time that if any of y'all want to come up and try it, we can see if we work it in. All right, so let's see. We have a couple of things. The main thing is the Zirconium trajectory editor. There's also an application for setting up building speaker layouts. And then there's also a video player which allows you to basically synchronize video playback with your Zirconium projects. But this video player, I also made it so that it can be useful you can sync it up to anything that can send MIDI clock or timecode or OSC. So it's a generally useful thing, but originally developed for Zirconium usage. All right, so Zirconium it's a number of things. One, it's a sound spatialization engine, which essentially means it does a whole bunch of math to figure out how to go from I want a sound here to then controlling the speakers so that the different speakers have the right amount of gain. So to begin with, I am not a sound spatialization expert. Even though I'm here in front of you, I do not have years and years and years of working with this particular kind of techniques. It's been interesting getting into it. I would say that Chikashi definitely has that as a really solid background. I'm continuing his work. So I will not, if I use the wrong term for spatialization this, blah, 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 then, please forgive me and tell me later so I can say it right the next time. But essentially the idea is, if you think about mono, right? Mono is one speaker. If I play a sound, it comes out of one speaker, right? And I can control how loud the sound is. Okay, there's no spatialization other than the fact that I have the one speaker somewhere in the room. If I have stereo, right, I can play a sound out of one speaker, I can play a sound out of the other, and I can sound like an early Beatles recording, right, where you're hard panned left or hard panned right or somehow mixed in the middle. Now what we're used to with pretty much all stereo audio is that you can mix the sounds. So you can say, all right, I have a sound which is equally as loud in the right speaker and the left speaker. That means it sounds, to me, it sounds like it's in the middle. If I have more gain over here, then the sound sounds like it's over here, right? And if I have more gain over here and less gain over here on the sound, it sounds like it's more over here. And if I have it all the way on one side and nothing on the other side, then it's hard left or hard right. I don't know which side I'm going on. But the point is, sound spatialization, we are completely used to it already. The only thing used to thinking of it is 2 years, like with headphones or in stereo. And when you add surround sound and you basically add 2 speakers behind, or 5.1, which is multiple speakers, one in the middle, all you're essentially doing is saying, I have a sound and I want it to play more out of one side here and then less out of over there. Or if I want it to sound like it's completely surrounding me, then I say, all right, I take the sound and I make it play equally out of every single speaker around me. Right? And if I say, all right, now I want it to be in the back of the room, then all the speakers in the front here, the sound should turn off and it should only come from over here. And then it should come from these two, so it sounds like it's the middle. And then it should only come from this one, so it sounds like it's over there. And then basically we move it. All we're doing is we're controlling how loud the sound is through each speaker. And that's basically what's going on here. There are a number of different algorithms, essentially techniques that you use to calculate, all right, what is the gain between these speakers to make it sound like it's over there versus over here. And naturally, the important thing is that the speakers have to be in the right position for this to work. It's the same thing with stereo, right? If you get the right channel connected to the left channel and the left channel connected to the right channel output, then the stereo panning sounds backwards. It's the same thing here. If I have this layout all mixed up, then the sound will be all over the place. And that's why included with Zirconium there are a number of tools to, one, create a file that basically says, here's my list of speakers, here's where they are in the room. And then you also have a way to remap which speaker goes to what. But that's essentially what's going on here. Okay, so that's the server part. The server basically takes, all right, sound files or live sound input channels, and then basically says, all right, tell me where you want the sound to be, and I'll do the math to figure out where it should be. And you can think of it as sort of like there's a little gnome with a boombox, and that little gnome can run around the room. The nice thing is you don't have to think about all that low-level stuff. All you think about is this gnome. You say, Mr. Gnome, go up in that corner, and that's where I want you to play your sound from your boombox. And then you say, all right, Mr. Gnome, go over here now, go over here, go over here. And the idea is working with artists, not that artists can't figure out this math, not that artists can't make the software to do this. The idea is the artist should make that work and not have to be making these tools all of the time. So we support the development of the tools so the artist can create the work, not the tools. All right, so let's get into something real quick. So first thing I want to do is make sure I'm connected to the right audio. Yep, cool. Now I will load, now there's a number of speaker setups here. So for instance, if I load quadraphonic, I have 4 speakers arranged in a cube. That's just that speaker layout. If you wanted to turn it so it'd be more a diamond, you can do that. However you want to place the speakers. Or I can do stereo, which is of course just 2. Or let's do the Klangdom instead. A bit more impressive. All right, so that's essentially all of the speakers in the room. In this particular layout, that is. I'm going to start a test tone. All right, so that's behind me. Oops. So it's oriented towards the top, similar to Garth's image from the last presentation. Towards the top is the front of the room, and towards the back is on the bottom. And right now we're displaying how if the gain is louder, then it is more red. All right. We can turn that off. Okay, so we got a basic setup working. So I have a couple number of things here. We have sources, IDs, and events. Just as a quick overview. So a source is essentially some kind of input. Either it will be like a sound file, or a channel within a sound file, or it will be live input. Or in the future, I don't have it working for this version, but in the future I would like, how many of you all have used Jack to communicate audio from one application to another? Oh, sorry. Yeah, Zirconium does not have support for that, but it's definitely on my big to-do list. That would make it much more flexible to just play sound out of, for instance, Ableton directly in. So right now you can use live input, as in if I have one computer, I can stream sound from a laptop in to the second computer, no problem, but I think it should be able to do it on one machine. Anyway, so we have some live input, so we'll start with that. Right now, this machine can have 64 ins and 64 outs. So the next thing conceptually is, all right, I have a number of input sources. Now I have an ID. And an ID is basically just to say, all right, I want to map a source to some sort of, to an ID that I can then move around, and then I can then essentially work with it with events. And events are essentially just things that happen in time. So I have an ID, which is kind of like a track down here. Let's make this bigger, sorry. So if for those of you that have used a digital audio workstation, each track is essentially like an ID. An ID is, again, one source. You can reuse the different sources, but an ID is just chooses one particular source. And an event is essentially something that happens in time. So an ID is basically the little gnome with his boombox, playing a particular sound or live input feed. And an event is basically you telling the gnome where you want him to go and how long it should take for him to do that. All right, so we have an ID, and I'm going to map that to live input and channel 1. And here, for those of you spatial audio nerds, you can choose either VBAP or HOA as your algorithm, or if you want to implement your own direct control, you can also use OSC to send how you want the spatialization to work, or you can just turn it off and then do a direct out connection. If I want input 1 to connect to speaker 4, I can do that directly, depending on your situation. I'll stick with VBAP for now. All right, so now I have a track, I have an ID, and then over here, that's live input 1, which Ben has helpfully mapped to the microphone here. Da 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 da. Oops, sorry. Da 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 da. Hello, hello. I'm behind you. Da 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 da. Hello, hello. Hello. I'm behind you. Now I'm over here. Now I'm over here. Now I'm over here. Hello, hello. Okay. So you have an initial point, and then now we just start adding events. Boom. All right, so I add an event. I say it's to ID 1. This is a little bit of the boring side, but it's part of the demo. All right, I'm connected to ID 1, and I say I want it to take, starting at time 0 to 10 seconds in, let's say 20 seconds instead. All right, 20 seconds. I wanted to start, all right, so let's say it starts in the middle, and then event 1 says, all right, Mr. No, I want you to go from the middle, I want you to spiral out. Oops, sorry. And end up in the back. Okay. And so what's nice too is it generates for each of your little events, it has a trajectory that's attached to it, and now we have a thumbnail, so you have an easier way to remember what it looks like. So let's go ahead and play it. So I have to talk right now. Blah 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 blah. And you can see this being stretched. The polar representation can make it stretch into this, just a 2D element here, stretched sideways. Now what I can say is, again, the computers are really good at really complicated math. If I want to say, I want you to do the exact same movement, but I want you to take 5 seconds instead of 20 seconds to do it, right? It would be dumb for me to have to redraw it, because the computer can just figure out how quickly it should move and do the math to move between. So it does that for us. So if I say, instead of taking 10 seconds, let's say, take 5. Now it's shorter here. If I restart, it did it in 5 seconds. And again, we can also create new trajectories, or there we go, I created 2. Create a new event. I created one here, which is really tiny. But let's say it goes from, within our piece, it starts at 15 seconds in, and it goes to, 20 seconds. Now, of course, I accidentally created 2. Delete that. 15. Okay, so now in our piece we have the same input. We tell the little gnome with his boombox, start in the middle, spiral out, stop in the back, wait 5 seconds, and now I want him to jump to the front, and then jump to the side, jump to the side, jump to the side. So that's what we'll do here. So, oops. So now we'll say, all right, and what it is when you select an event, it actually shows you where it ended the last time. So if I say, select here, I know my gnome starts here, and then it goes out, and it goes out, and it goes out, and it ends up in the back. Hold on, let's make this easier to see. Let's turn the speakers off. Yeah, just click like this. This is something I want to change in the future. It's hard to do this. Okay, so now we don't have to think directly about the speakers. Alright, so essentially he moves out and he ends up here, he starts here, he ends here, and then the whole time that the sound is playing, it stays in the same spot for just 10 seconds, and then at 15 seconds, it can move to the end here. So all we have to do is, we'll select this, and then we'll say, alright, I want you to move from here to here, then here, then here, then here, and then here. We'll end up in the back. Alright, so if we go back, we can preview this. So we do our piece again. We can make this a little longer, I'll say 10 seconds again. Okay. Let's go back to the beginning. Now it stays put in place again. So with live input, so you could, as you see, you can use it for live performance if you want to. But you can also use existing sound files. So I can say, right, I can say I have a number of pre-recorded, pre-rendered from the audio files from the Next City Sounds project. Basically, sounds around files were recorded for over 1 year of audio in multiple locations in 2016. So we're using it as a sound source for new projects. And so this was basically taking those individual hours and then removing all of the quiet sounds, so you only have the loud sounds left. That's why it sounds very weird. Here. Do the better one. Okay, so I can add this as a new source, and it has one channel, so it's a mono file. And I can create a new ID. And yeah, complaints about that. That's too bad. The system is set up for 48K, and I've not converted these from 41 to 48. So it will complain, but it will still work. Right. So I have basically two IDs. ID 2 is now connected to this sound file, and ID 3 is now connected to this sound file. And you can see it rendered. So if you're a composer who's already pre-rendered all of your different audio files or channels, and you essentially want to just move them, and you want to be able to see, you want to be able to match movement with, like, let's say, amplitude. We can actually see the waveform representation in the timeline here. So I can say, all right, I want it to move really quickly when it gets really loud, and then stop. And the idea with representing this way is it should make it easier to do that. So these are relatively short, I think. So we'll make a couple more events. I'll say event for ID 2. What sounds like? Media sold. So let's start him. He starts here. I want him to move. Say like this. Now, one thing you'll note is in the dome view here, it renders the waveform along the path so that you can also figure out where you want the sort of the dynamics to lie. If I just draw a straight line, it fits there. This is for some reason loading it really quiet. Well, it should be longer. I'll check that out later. Let's see. I think it's only 10 seconds, that's why. Let's make this, hold on, let's see. That whole sound is almost 3 minutes, so I'm going to make it 3 minutes long. Okay. Okay. All right, now it's going to take way too long. Let's do it 10 seconds, maybe 30 seconds. Oh, it's 30 minutes. So yeah, interface-wise, some things are really nice, other things could be improved. That's an ongoing thing. As Ludger mentioned, there's been multiple people working on this project, and some of them have taken different approaches to how they work on the interface and how it should be useful to artists. And I think we're at the approach now where we have version 1 has one particular approach to doing it, which is much more of a compositional, mathematical composition, where you say you should move from here to here in this number of degrees and this amount of time. And obviously Mark 3 is very much of the I want to draw, right? But if you want very precise things, it's a little harder to get that with just drawing. So one of the things that I'm working on with newer development will be merging in both of those approaches to composition into the same tool, and also making it extensible for people to work to have more, for instance, direct control. Like if you build your own tools and you want to, for instance, control the spatialization aspects with OSE or run things live, then that's definitely something I want to support. All right, sweet. So let's add an event for this guy. All right, that's event 3. And let's make him bigger. I think I made it tiny again, didn't I? let's see, delete. All right. So we can shift it along the audio file. And can make it bigger. Okay, that's better. Yeah. One of the problems, though, development-wise, is if you make something as complicated as a digital audio workstation, it's a lot of work. And the expectation of how it should work is very high, because people see that and they say, oh, I know how that works. Now it should work just as well as the one that's from a gigantic company with many hundreds of people working on it. Whereas right now I am one person working on it. So, all right, and we can make this longer or shorter, etc. Here we go. Now it's rendering better. So you can see here, rendering along the path. Here, no. There. Now you can see it rendering along the path. And if we do a curve like this, I can move the points so that, for instance, I want this dynamic to be where the corner is. Okay. Another thing is these are also Bezier points, if you want to make nicer motion curves. And there's a centroid there. There's a number of other elements too, so as you create your different IDs, you can also group them, and then they're connected, and then you can sort of also rotate them together. If I wanted to, I can also say, I created this path that I like, but I want it to be bigger. Well, I can just move it around so it fits better, or not at all. So again, the idea is that if you're working with this, it should handle a lot of the basics of the spatialization without you having to go in there and be like, I have to figure out the math of how this works and blah, blah, blah. And there's a number of live controls and live techniques as well. Yeah, I can get to that. But first I want to talk about the other tools. So as for the speaker setup, the idea with that is, again, the whole point of this is two things. One, if you create pieces with the Zirconium software, you should be able to play them back in different environments. So, for instance, built in, if you don't have an access to a space like this, or to the mini dome, which is basically it's a 23, 24 channel miniature version of this in a studio upstairs, then you always usually have headphones on your laptop, right? So built in is essentially a headphone spatialization representation. It does some math to simulate the spatialization movement, but just binaurally with headphones. It's obviously not as good as the real space, but it gives you a basic idea. And if you wanted to, for instance, just go home and set up like a 8-channel or whatever and map it around your room, what you can do is you can use this tool to say, all right, I have a 2-dimensional, or let's say I have a 3-dimensional, let's say I have like 4 speakers on the floor and then 2 in the ceiling in front of me. So I can create a number of speakers. And then I can basically say, all right, so speaker 1, let's see, where's speaker 1? Should be, let's see. I can basically, there's a couple ways to do it. One, you can measure how far away it is. Let's say it's 4 meters. And elevation, azimuth is essentially, there's 2 ways to think about it. One is from the point. Azimuth is basically the degree around the circle you are, and elevation is how high up. You have an arc. The speaker is at the end of an arc, and my armpit is the center. Elevation is basically going up like this, and azimuth is basically turning like that. Another way to think about it is you can think of this in meters. I can say, all right, it is in front of me and at the same elevation. Well, it's actually next to me, but you get the idea. So if we do it speaker 3 and we see that that's -1, then whoops, it's in my head, -1. There we go. All right, so we have 2 on this side. So essentially, you can actually measure things out and figure out exactly where they are within the space, and then from this you can output a file that you can then load in Zirconium, and then you get that layout. So I'm going to be lazy. Let's just leave this dumb-looking output here. And then we'll say, let's export it. do it on the desktop. Okay, so now we have an XML file, and then I can load it. So, okay, now I have to turn the speaker's view back on so you can see them. Okay, so there is my weird layout again. And it will only use, what, 6 speakers if I run this spatialization. Or not, because they have a different layout. I probably have to reconnect the audio. Nope, okay. Well, that's the idea. So one of the things is if you're an artist who's worked with spatialization before, and you think about, I have 2 channels and I can mix myself between the 2 channels, or I have 4 channels, I can mix myself between the 4 channels, or if I have 8 channels, I can mix myself between the 8 channels. But the thing is, that means now you have 3 or 4, you have multiple different versions of the work, right? Because you have to remix it based on the position of the speakers or the number of channels. And if we start to add more and more speakers, then you end up spending not so much time actually working with content and creating a piece, but just rendering different versions of it. And one of the points of Zirconium is that you can not think about the number of speakers at all. Just think about, I put my sound here in space. And then Zirconium will handle whether it uses 2 speakers that should be like this, or 4 speakers that should be like that. And if you want, you can also use Zirconium to render each channel out individually. So you can bounce something for 64 channels or for 8 channels, but it's the same piece. You don't have to manually tweak the settings, etc. And I think that is a very useful point about it. Okay, so that's the speaker layout. Okay, so one more thing would be something that I've worked with a lot of input from our tone meister, Ben, and he's been using it, the last 6 months for on and off for different projects, is a video player. So it kind of looks like, just a regular old video player. Not that much different from QuickTime, except that we have a number of options. And one of them is that we can control it over OSC or we can control it over MIDI. And it natively already speaks, listens to the messages that Zirconium can send. All right, so I'm port 5555. I will connect this to the network. Let's see. All right, I'm already set up to listen, local network 5555, to receive QT, QuickTime. That was the name. This is an updated version. There was an older version of this from Mark II called Zirconium, QuickTime Blair? Yeah. So this is, so we have a number of pieces that are already, that basically are a number of Ludwig's pieces actually, where you have the sound is being run from Zirconium, and then you have a video that is being synced live with the playback. And so this is just basically the next generation of that tool. So if I set this up, let's see. Right, let's see. If I get in trouble with demoitis or not. You do it at home and then it doesn't work here. Let's see. That is enabled. That is on. Okay. Let's see, make sure OSC is on. Okay. Yeah, okay. So there you can see it. It's just that the piece is relatively short. So the idea is here, let's say, here we go. So as the piece is playing, you can synchronize your video output with your Zirconium playback. And I just chose a very a boring video with a long intro. And if we want, we turn that off. And now we can do playback with a live piece. I just don't have a good demo piece to show, but the basic idea is as you move Zirconium around, it also moves the video player, and then it keeps it in sync. Once you play, that is. Okay, so that's a useful tool. And again, that's useful for not just for Zirconium, but other things as well, if you want to download and use it for other things. I tried to make it, so again, as Ludwig mentioned, I work with a lot of open source projects and with making my own tools as well as tools for other people. And I try to make things useful in many different ways beyond just how you make one particular thing. So to make things extensible, like the video player, I could have it just listen to Zirconium and that's it. but I thought it's worth the extra work to make it listen to a digital audio workstation that can send MIDI, or my phone, which sends just an OSC message from like Touch OSC or whatever. That way you can use it for all sorts of things beyond just only working with zirconium. And then you can, you have a tool that's more generally useful, and you don't have to keep making the same thing over and over and over again. And that's actually something that I would like to do with zirconium. So again, one of the issues is that it's built right now, Chikashi's implementation, with a very good implementation of working with the Bezier curves. It's very nice and gives you a lot of interesting opportunities. And the other point that I think is really good with this is most spatialization servers just do the server part, and at most your visual representation is a huge long line of faders, right? And as something moves, you say, oh, this channel goes up and that channel goes down. But conceptually, it's harder to see what's going on. You can hear it, but you can't necessarily see it. And if we're working with newer artists that are also coming from, we're working with a number of artists the last, year or so. Some of them have come from less of a electroacoustic spatial music background, and maybe more from the DJing scene, or my background is less in computer music and more in punk rock, actually, before I got into working with these kind of experimental things. And so for me, it's actually pretty useful to be able to say, I want the sound to be here in the dome or there, and I want to see its path as it moves in space. And for a lot of people, this approach has been very useful. And we definitely want to keep that. Let's see, a couple other things were, again, making things extensible so that you could say, all right, maybe my zirconium piece is not just a fixed thing in time, it is also a program that is running in, let's say, Macs, or maybe a zirconium can run a program on its own, and essentially you have a random generalization of movement live. Let's see, so it already has this built in, but I think it could be more useful. Let's see if I remember where this is, since I had the time. Yeah, here it is. So, also something that Ludwig mentioned is the spatialization server is actually built using a pure data engine. Okay, let's see. Connect. All right, so here's an example of, this is a separate application that is controlling zirconium, which actually at the same time is, I turn the video player off, but it would also control the video player playing. So if I want to integrate that into my own existing sort of more creative arts toolkits, as in composers or artists that are actually writing code and that is their output, not just a fixed piece, the idea is that you should be able to just mesh it directly in with that. So I can, at the very basic, I have basic playback controls, or I can also say, I want to move my ID, so I want to move the position live. So one thing with zirconium is you don't have to use any of this trajectories and stuff. You could basically just say, all right, I have 10 different live inputs, and here they are. Here, I set their initial positions, and then I have my software somewhere else or program that is actually moving them live, randomly or through some sort of algorithmic process. So we can do that now. So here this is live control, blah, blah, blah. Or I can rotate something. Hold on, let me move this back. All right, move this to the middle. And I can say, all right, now I can rotate around. So if I want to think of a rotation or in and out. And then we also have this element called span, which is basically like, you see this little circle coming out. It is essentially the virtual width of the gnome's boombox, right? So if I have a sound source that has no span, as in basically the width is essentially just one speaker. If I have a wide span, this is the same as Garth's approach, that we have a very wide field that triggers all of the different phones playing. Same thing here. If we have if the sound is very wide, the span is wide, it will play on multiple speakers. If we make it so wide that it covers the whole dome, then we should hear it more or less out of all of them. Okay, so we can control that, and then if I run the floodgate here, so this is, we're using randomization to essentially just move the sounds live, and if I'm talking blah, 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 can you pan me in? Shh. Look behind you, I'm right behind you. So again, this is a piece, you could say that this is a very simple test piece, but it's running live. This is an example of, okay, so we're not using the drawing elements, we're not using the sequencing elements of the Zirconium software, we're only using the sound spatialization. So again, my thought is, Zirconium can be useful in many multiple contexts, and it should be allowed for different ways of working. Whether it is you just use it as a server, or you use it to do all of the work. Either way, and the nice thing again is that you can bounce live what you're doing, and then you have let's say an 8-channel piece or a 4-channel piece or da da da. And you don't have to move things live either. You can also use it as a toolkit to say, all right, I have 50 speakers, but I want a virtual 8-channel playback. So if I have an 8-channel piece that I want to play on a 50-speaker setup, then I can load an 8-channel sound into Zirconium, and then I can set an ID, one for each channel, and I can say, all right, ID 1 is here, ID 2 is here, matching. You can essentially use the IDs as virtual speakers that can then play back your 8-channel piece, even though you're using 50-channel setup, which is what we've done for a lot of different pieces in playback for a lot of different compositional pieces here in the Klangdom. We don't have to think about addressing individual speakers. We just say, all right, we have virtual sources that go here. And depending on your algorithm, the sweet spot can be very wide or very narrow, how big your span is, and yeah, there's a lot of other nitty-gritty details for the electroacoustic spatialization nerds, but that's the basic idea of how this tool works. I think I've been able to make some improvements for the general usability and stability for this version, but don't look at this and say, I made this. Most of this is Dr. Chikashi Miyama's work. I'm just extending it and making it a bit more useful as a general purpose tool. And again, this is 3.4 beta. It's not on the website currently. It will be very soon. If you have a Mac and want to try it out, I've got 10 of these little USB sticks with the beta build on it, if you want to try. Can get them later. Let's see. Is there any other interesting major points that... VBAP HOA, okay, so now you're getting to my weakness, which is not being super familiar with how these work. Okay, so VBAP, so there's there are multiple algorithms, I believe, but we have two algorithms for calculating, again, like how loud a sound should be out of which speaker. You have VBAP and HOA. VBAP is vector-based amplitude panning, and that is essentially to say, you take this speaker's layout, and if any of you are familiar with the aesthetic of, let's say, 1980s or 1990s 3D modeling, right? You have a mesh between all of these speakers. And normally you can see it, but I think there's a bug right now that's not showing the triplet. Yeah, it's not. Yeah, drop the volume a little bit. We can see it with the gain. No. Okay, so how the VBAP works is essentially it says, all right, this is the layout of the speakers, and now it computes like this, 80s or 90s 3D modeling. It computes a mesh where you essentially have, I'll turn it off. You basically have just triangles. So this is a triplet of speakers, this is a triplet of speakers, this is a triplet, this is a triplet, this is a triplet, this is a triplet, blah, 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 blah. So the minimum number you need is 3 speakers. And then it moves in triangles. And then kind of like 3D graphics, if I put a point on this, in the middle of this triangle, and I go to the next triangle, then essentially the sound moves from triangle to triangle. And that's how it works out. So basically, to make a sound sound like it's coming from a virtual space between, let's say, these 3 speakers, then we say if I'm closer to that speaker, this speaker will be louder, the speaker farther away will be a little bit less, and then that one will have a little more. As I move towards the bottom one, that one, the amplitude goes down, and that one, the amplitude goes up. And then as I transition to another triplet, then the one speaker that's far away, let's say, if I go from these 3 to these 3, as I go across this border, this one turns off, and then that one turns on and fades in, and then we can hear the sound moving. And that's, again, built on this idea of this mesh, and then figuring out a point, all right, where is my point? Is it on this triangle, or is it on that triangle? And then where does it go from here to here? HOA, Ho is a bunch of polar math that I don't understand. Do you have an overview? Okay, sweet, yeah. Let's see. Okay, right. So let me make this big. So right now we're using VBAP for everything. Actually, let me just turn off those other ones. Now I'll try, let's change this to the Hoa algorithm. So in my understanding, the Hoa can give you, well, with VBAP, it's based on these triangles, and so you're limited by the resolution of the number of triplets you have. And the way that when you cross from the edges, the resolution is a little bit lower. On the other hand, and there's one reason why, as far as I know, the majority of pieces that we actually play in the Klangdom are VBAP based. I believe, at least that's what Gus told me. Is that your VBAP gives you a wider sweet spot, as in like you don't have to sit basically where the dummy head is back there to get the best sound. You can be on the edges and still get a good element of spatialization. And again, I could be wrong, but as far as I know, Hoa gives you better resolution, but you have your sweet spot is smaller, if that makes sense. You have to be more in the middle. Yeah.
Speed envelope.
The speed envelope?
Yeah.
For what?
And with one technique that might be another.
Oh, right, yeah, and that's a good point. So this new version, for the venues who've used this before, a couple of main things I've added, also in talking with Ben and some of the guest artists, is that, right, with VBAC, it's also, you have interpolation, like as a point moves, you also have how often you check where the point is, and then how much, essentially, you could say, I recalculate here, and then I wait like half a second. Well, it's more like a millisecond or whatever. And if you do that recalculation much more quickly, then you'll have a much better resolution of that movement along that line. If I only do it every now and then and jump like this, then you'll hear the movement. And that's what Goodger talks about. Like right now, it's built-in 25 millisecond interpolation. Every 25 milliseconds, it figures out the new position. If you have a fast computer, you could lower that. If you do it more quickly, the calculation more quickly, then you can have a better resolution. And that's actually something I built in to be settable. I just haven't added it to the interface yet. Another thing I've added is you can also set the gains. So the live input gain. So Ben, can you turn my input on again? Okay, so that's 3 dBs louder. Now it's 3 dBs quieter. 6 dBs quieter. 0, right back to 0. And that gives you a bit more control of, like, let's say you have one channel and you want to have multiple copies of it, but you say, let's say you want to have, I want to play channel 1 back in the middle, but then I have multiple IDs on the side that should also be playing channel 1, but they should be like really quiet. You couldn't do that before with Zirconium. The earlier version, you had to basically like render out a different version and load it in with just a lower gain. And now I've added control for that, as well as control for the sources. So that's a good thing. If you've never seen this before, you're like, okay, great. If you use this before, you're probably like, yay. Yeah, and a lot of that should be controllable over OSC. That's another thing I'll be working on. Okay, so I'm over time, and I would say... Check. I would say just in real quick that a couple of the ideas are, and thinking in similar ways to Garth's phone project and that infrastructure is ways to make this software and maybe this approach useful in other contexts outside of just this large infrastructure. So thinking about, so one thing is Zirconium actually, it's half open source, half not. The server itself is, you can find it on GitHub, the pure data based audio server, so you can run it as just pure data patches. And I'm thinking about ways of integrating that and to make it work with, for instance, Raspberry Pis, and then distributing multiple Raspberry Pis. I think phones are even better. This is not something we could really wrap into like a web-based protocol, but basically a ton of small, cheap devices located in different places with, let's say speaker systems from the thrift store. You could build a version of this maybe in bricolage style. It wouldn't sound as good, but it would open up a lot of possibilities in different ways. And that's some things I'm thinking about. So yeah, that's where we are. Thank you.
Thank you, then, Wilcox. Are there any questions? No. Oh, there are. Okay.
Sorry. Yeah, thank you for your demo. I guess I like this parallel approach, so that you can model different, let's say, lines to play or to schedule different speakers. In my head, a question raised. The problem comes even harder if you have different sources, in fact, and you want to distribute different sources. For example, you have 8 sources and 8 speakers or 8 monitors. Is there an approach in the software to model something like this?
Yeah.
Or did you show this?
You can create a different. You just create a different ID for each channel.
Okay. So you didn't show it, in fact.
Yeah. Actually, that's a good idea. I'll put a stereo channel in, and then you can see it. It won't take very long. I just have to find a stereo file. Let's see. Okay. Well, we'll do live input.
I believe it.
Right. So I create 2 inputs, and I say, all right, I have channel 1 and channel 2, and then I can say, if I wanted to, for instance, ape stereo, I would say, here's the left channel. There's the right channel. And now you get the sounds coming out of here, coming out of there. That's what I meant, like, if I wanted to, let's say I wanted to simulate an 8-channel playback with the dome, then we create 8 IDs and then place those in the circle around based on the position.
A fixed schedule or something?
Yeah, that can be fixed. Yeah, fixed. I can just leave this, and now we'll just play out of that position always.
But you can also play with different input channels.
Yeah.
Right.
Yeah.
So it's an M to N matrix, in fact.
Right.
So indifferent of.
Yeah. So there's multiple layers. I can reorder the source live input to a different channel if I want, or in the outputs as well. Okay. And yeah, this again, the idea is flexibility.
So my question refers to the implementation of the jack functionality, as I'm obsessed with using sound which comes out of web browsers. So can you already say when this will be implemented?
Monday, maybe.
On Monday, that sounds awesome. So maybe then I have a second question, which it's connected to a very particular use case. I'm not sure whether QuickTime is capable of producing, let's say, several entities playing back video simultaneously. Do you know about this?
You mean like multiple video?
Yeah.
Play? Yeah. We can ask our tone master. That was one request of his. Yeah,
that's for Tuesday. Okay,
yeah.
So then on Tuesday,
it would be possible to make the video player basically. Yeah, you can load different videos and then just have multiple versions of the video player playing. Mm-hmm. Yeah.
So I just want to check out whether I can then do a multi-channel video installation with sound coming out of web browsers, which can then get spatialized by Zirkonium.
I would say that yes, a little bit of work, but yeah.
Maybe Wednesday, right?
Well, no, I'm on vacation. How about the day after Christmas?
You could do it tomorrow if you have multiple computers and you could address multiple IPs with OSC.
Yeah, you can do that now. You can basically just play out of your laptop into the computer running Zirkonium.
I would prefer not having 6 computers, but maybe 1 computer with 6 video outputs. Very particular use case.
Yes.
Is it possible to record the trajectories in real time?
Record in what way?
With the iPad or...
Yeah. Actually, I just don't have time to do it. And there is an application called ZirkPad, which is on the App Store. I've not worked with it too much, and we didn't have that much time, so I didn't want to kind of try and make it work in front of you all and then have it fail. But this is also developed by Dr. Chikashi Miyama, and essentially you have a representation of the dome, and then you can load, it talks to the zirconium, and the zirconium says, hey, I have these 8 IDs, and then it gives you the IDs with a color matching, and then you can say, all right, ID, move from here to here, and then there's a record mode. That's what this is for. You hit that button, and then you just move it, and it records that, an event with it records the path. So,
multiple iPads.
right. And because it uses OSC, you can also, like the little PD patch that was generating the movements, I could record those. It doesn't care where it comes from. It just processes the OSC messages and then records the positions.
On the last row, the last question.
Hello. Just wondering if there was a easy way you could do it with CV, with like modular synths.
With the control voltage? Yeah, essentially if you, input or output?
As in, I'd send voltage into the
computer to control, let's say, like a position of something?
Yeah.
Yeah, that would be... Yeah, I would go do it in the PD patch. Basically, then you can just use I mean, you would need some way to make sure the CV doesn't fry, but if you have some way of getting in as an audio signal, or if you have, better yet, you can buy these CV to MIDI converters. I don't know how good the resolution is. That's actually what I would do. And then you can take the MIDI, and then using something like Max or PD or some other small, tiny utility program that can convert from the signal coming in and then send an OSC message to Zirconium. And it would totally work. This is actually a third thing that I wanted to add, which is that, again, when internally Zirconium is running a PD patch for the server, and I would like an ability that you could say I have an ID, and the ID also runs a very tiny PD patch on its own. So you could have that built in. Like part of your piece is both the trajectories and the locations and the mappings, but it's also a tiny program. So that would make that a bit more flexible. But yeah, a little bit of conversion and then just make it talk what it needs to hear. Boom.